Want us to check this principle of conservation of linear momentum. So this is a fundamental principle in physics that states that the total linear momentum of a closed system remains constant or remains conserved if no external forces act on it. So this principle basically is based on Newton's third law of motion. Okay, because Newton's third law of motion states that for every action, we know that there is an equal and opposite reaction. So when we are breaking down this concept, we focus on the conservation principle. So it says the initial momentum, the initial momentum is equals to the final momentum. So this means that the total momentum of a system before interaction is equal to the total momentum after the interaction. Okay, provided that there are no external forces that are involved. So symbolically, when we talk of the conservation of linear momentum, we say that the sum of the initial momentum must be equal to the sum of the final momentum of that interaction. Okay, so when we expand this, it says that if we are going to have mass 1 multiplied by velocity 1 plus mass 2 velocity 2, which is equals to, so this is the initial stage. So it means everything here it's initial. And then when we go to this other part, it says that this is mass velocity, this is mass 1 velocity 1, but in the final stage, plus mass 2 velocity 2 in the final stage. So this is the formula. This is how one can expand this conservation of linear momentum formula. So from this formula, when you expand it in this way, it can differ. Okay, it can differ depending on the situation given. Sometimes the two masses, they can share a velocity initially, like they can share a velocity. We can say this is v into mass 1 plus mass 2, and then find out that later the two objects that were in contact, they separate. Then we can have something like this. Sometimes we are having the opposite of this formula here. So in order to understand the conservation of linear momentum, this fundamental principle of physics, I think we should look at an example so that we get the gist of this concept. Here is our example. We are given that a car of mass 4000 kg travels due east at this velocity 1.5 meters per second. The car driver tries to link it to a stationary wagon of mass 3000 kg by letting them collide. Instead, the wagon moves due east with a velocity of 2.8 meters per second. So they want you to calculate the magnitude and direction of the velocity of the car immediately after collision. So now let's draw the situation. So at first we're having a car. This is our car, and then this car has a mass of 4000 kg, and it's traveling at our velocity here. It's 1.5 meters per second east. All right, so let's do this. This is our north, this is our south, then this is west, this is east. So it means this car is traveling in this direction. This is the initial part. This is the initial part. So the driver tries to link this car to a stationary wagon. So it means somewhere around here there is a stationary wagon. There is a stationary wagon, and this wagon has a mass of 3,000 kilograms. So it was at stationary. It means its velocity is 0 meter per second. And then now this was the initial stage. Then on the final stage, what we know that is that the wagon moves due east with a velocity of 2.8 meters per second. So it means that this car and this wagon collided. So now let's suppose now this car is at this point somewhere around here. This is our car. Then we have our wagon here on the final stage, and this wagon now, because it has collided with the car, then it start moving due east with a velocity of 2.8 meters per second. So they want us to calculate the magnitude and direction of the velocity of this car here after the collision. So in situation like this, we're going to use the conservation principle or the conservation of linear momentum. So the formula says that the sum of the initial momentum must be equal to the sum of the final momentum. Remember, we're having mass 1 v1 plus mass 2 v2, which is equals to mass 1 v1 plus mass 2 v2. All right, so mass 1 will be the mass for the car, and mass 2 will be the mass for this wagon. Initially, which is this stage, initially we had the mass of the car, which was 4,000. And before we can do that, let's choose direction. We take east as, we take this as positive. All right, so mass 1, this is our mass 1, which is equals to 4,000. Then this is our v1. Then this is mass 2, which is 3,000. This is v2. So everything on this wagon will be considered number 2. Then initially the mass of this car was 4,000. This we had 4,000 kg multiplied by the velocity of this car, which was 1.5. Then because it's going in the eastern direction, it means it's positive 1.5 plus the mass of this wagon was 3,000. We had 3,000. Then we multiply that by 0 because it was at stationary, which is equals to the mass of this car at the final stage. Because the mass obviously didn't change, then it means we are having 4,000 multiplied by the velocity that we are looking for, the velocity of the car. And then now here we are having the same mass of the wagon, which is 3,000 multiplied by this new velocity of the wagon. Then it means we're going to add 3,000 and multiply this by positive 2.8. Then this one will give you 0. Then when you punch this on your calculator, we get that it gives you 6,000, okay, plus 0, which is equals to 4,000 v plus, and then when you punch this on your calculator, you get 8,400. Then we simplify this. We can take this to this other side, okay, this side, and then it will change its sign. Then we're going to have negative 2,400, which is equals to 4,000 v. Because we're looking for the velocity, we can divide both sides by 4,000. We divide both sides by 4,000. Then our value of v becomes negative 0,6. So remember here we took the direction. Okay, we said the motion going in the eastern direction is positive. Then now here we get that our velocity is negative. So it means our velocity, or the velocity of the car after the collision, it's now 0,6 meters per second to the west, or in the western direction, because this is what the negative sign is telling us. So it means if this motion going to the east is positive, it means any motion going in this direction has to be negative. So I hope you understand this question and you understand how we came about the solution. All right, so without any waste of time, I think we can look at the second question. Here's our second question. It says a boy of mass 40 kg runs at 5 meters per second east, jumping onto a skateboard of mass 2 kg moving at 3 meters per second east. So they want you to calculate the speed at which the boy and the skateboard are moving together. Okay, now when we try to analyze this situation, okay, we are having a boy, then this boy has a mass of 40 kg, and then the velocity of this boy, it's 5 meters per second east, and then the boy jumps on a skateboard. Then it means here, somewhere around here, we're having a skateboard, and this skateboard is having a mass of 2 kg, and then this skateboard had a velocity of 3 meters per second, and then it's moving east in that direction. So this is our initial stage. Then on the final stage, we know that, okay, this boy now jumps on this skateboard, and this skateboard was moving at this certain velocity. So the final stage is that the boy jumps on this skateboard, on this moving skateboard. So the boy now is on the skateboard. So they want us to calculate the speed. They want the velocity at which the boy and the skateboard are moving at together. All right, so it means that initially mass 1 was 40, and then mass 2 was 20. Then our v1 was 5 meters per second, our v2 was 3 meters per second, and then we take east as positive. Then now the boy jumped on the skateboard. Then it means the mass of this, it means the mass of this is the mass of the boy plus the mass of the skateboard, which is equals to 40 plus 2, then which is equals to 42 kg. Then they are looking for what? For the velocity. Then we can use the principle of conservation of linear momentum. Then the sum formula is equals to P final. Then notice that at first they were separate. Then it means we are having mass 1 v1 plus mass 2 v2, which is equals to, now the boy and the skateboard, we consider them as one mass. So it means they are sharing what? The velocity. Then we can make the v or let me do this, mass 1. We know that it was supposed to be mass 1 v1 plus mass 2 v2, but in this case the mass, we consider it to be one mass, which is the mass of the boy plus the mass of the skateboard. And then the two, they're going to share what? A common velocity. And then here we're going to have mass of the boy, velocity of the boy at initial stage, and then plus mass of the skateboard and the velocity of the skateboard. So initially we were having 40 and 5. So it means here we're going to have 40 kg multiplied by positive 5, because we took any motion going in the eastern direction to be positive. And then now plus the mass of the skateboard was 2 kg, and then the velocity was 3. Then it means you're having 2, then positive 3, which is equals to, and then here we're going to have the mass of the boy, which is 40 kg plus 2 kg for the skateboard, and multiply by the velocity there. Then it means on this side we're going to have 42 v, and then here we're going to have 200. 40 by 5 is 200, plus then when we multiply the 2 you get 6. Then now it means the sum of this is 206, which is equals to 42 multiplied by our velocity there. And then we divide both sides by 42. Then our velocity now becomes 4,9 meters per second. So notice that we got a positive answer. So remember, positive, it was going in the eastern direction because they wanted the speed. Okay, and the speed, which is our velocity, we know that velocity is a vector quantity, so it needs direction. So this positive answer, it means that it's going in the eastern direction in that way. I hope it makes sense. If I'm talking nonsense, you can let me know in the comment section, and then I will try to re-explain this concept. Okay, I think we should do another example. Then now we're given a trolley of mass 3 kg which moves at 4 meters per second west along a frictionless horizontal path. Let's draw this situation. We're having a trolley here. This is our trolley. And then this trolley has a mass of 3 kg. This is the mass of this trolley, which is 3 kg. And then it's moving. The velocity of this is 4 meters per second west. All right, on a horizontal frictionless surface. So this is our horizontal frictionless surface. So according to our cast diagram, or our compass, so this is our north, south, this is east, this is west. So it means this is going in this direction. Then now they say a brick of mass 1 kg drops vertically into it. We're having a brick. We're having a brick here. This is our brick. And then this brick is having a mass of 1 kg. And then it drops into this trolley. Then they say the brick lands on the trolley at a vertical velocity. So the velocity of this brick when it was going down was 0.5 meters per second. Now they want you to calculate the velocity of the brick and the trolley system after collision. So this was the initial phase. We had the trolley going in the western direction, and then during its motion there was a 1 kg brick which was vertically dropped into this trolley. So at some point here, our trolley is here, and then inside this trolley we are having a 1 kg brick. Then they want you to calculate the velocity of the brick and the trolley system. So it means the mass now, it means we're going to have the mass, which is the mass of the trolley plus the mass of the brick in this situation. So which you are going to have 3 kg plus 1 kg, then it gives us 4 kg. So this is the final mass, or the total mass of the system after collision. Now they want us to get the velocity of this system. So in order to answer this question, we are going to use the principle of linear momentum. Excuse me, here it's final. We're going to use the principle of conservation of momentum, of linear momentum. Remember, we're talking of linear momentum. Linear, we consider linear to be on a horizontal plane. But here we are having a situation whereby we are having a brick which is dropped vertically into the trolley. So if you're given a situation like this, it means that the brick, okay, we know that the brick strikes this trolley vertically at 0.5 meters per second. All right, so the brick horizontally, it does not have velocity because the brick is not moving in this direction, but it's moving in this direction. So, and we are talking of linear momentum, and when we talk of linear momentum, we talk of this horizontal plane. So this brick does not have a linear or a horizontal velocity, and momentum is conserved in a straight line. When we are applying this conservation, we apply this conservation on a straight line, not on a vertical line. So when we apply this law of linear momentum, we consider the velocity on a straight line. So in this case, one thing that you should know is that the velocity of this brick, because it's a vertical velocity, then we ignore it. It means initially at the initial stage, we had the mass of the trolley, which was 3 kg, and then it was moving at a velocity v of 4 meters per second in the western direction. And then in that initial stage, when this trolley was moving, we had a brick, okay, this is 1, and then this is mass 2, then velocity 2. This is for the trolley, and then this is for the brick. The brick was having a mass of 1 kg, and then its horizontal velocity was 0 because this was dropped at a vertical. It only had a vertical velocity, so it means the horizontal velocity, we consider it to be 0 meters per second. And then we had our final stage whereby we had the mass of the trolley plus the mass of the brick as a single mass, or as the mass of the system, and then they wanted the velocity of the system. Then we know we can calculate this to be 3 kg plus 1 kg, which becomes 4 kg. Then they want the velocity there in the final stage. Then we're going to use the principle of linear momentum, or the law. Then when we expand that formula, we know that it's going to be mass 1 v1 plus mass 2 v2, which is equals to, now the two masses are combined, they share the same velocity, so it means we can say this is mass 1 plus mass 2, and then they share the same velocity, just like that. Right? So remember, they said to us this is moving in the western direction. Yes, this was moving in the western direction. So we have to take direction. We can take the motion of the trolley to be positive. So any motion going in the western direction can be positive. So it means any motion going in the opposite will be negative. Then now we were having the mass of the trolley, which was 3 kg, then plus or multiply by positive 4, then plus, then we're going to have 1 kg into 0 according to our information here, then which is equals to, then we're going to have 3 plus 1, then multiply by the velocity there. Then here you will have 0, and then when you multiply the 2, it gives you 12, which is equals to 4v. Divide both sides by 4 to make v the subject of the formula. Then now our velocity v becomes 3 meters per second. And then because we got a positive answer, it means this is also moving in the western direction. So this is the conservation of linear momentum, or this is the fundamental principle of conservation of linear momentum, and how we apply this formula at different scenarios. All right, so if you have any inquiry, you can comment there, or you can email me. I will leave my email in the description of this video. So from me to you, see you in the next one.